baby of the beetle is a sapsucker.
No. The baby of a beetle is a borer.
Oh.
Yeah. Okay. Well, there's so many different types of beetles, but you actually do get some borers that are actually an order into themselves. The name of that order, I can't remember. What is that? It's my thinking at the moment.
It's a nice looking tree, isn't it?
It is. I'm
you
wrecking
know
it more. I feel I'm damaging the tree. But like you said,
I'm not so much into biology, but come have a look at this. This is interesting. Here we are at Springbrook. Leave those two. This is Springbrook. This is the interesting thing. We've modelled the earth here. We've got some good things happening now. We've got
Here we go.
the vine. The vine represents the circle, and here we have, very hard for me to do this. This is the radius. This is a radius. This, of course, is the centre. So, of course, from there through to here is a diameter. This is a radius. This is a radius. This represents the height
Of the person.
But it's a great
And
big.
the elevation.
It's not very. It's like this would be like a satellite height.
Elevation, right.
But this is the elevation, the height, and from there to there is a tangent. So this distance here is the furthest this person can see to the horizon. After this point, he can't see down here because it drops away. Sorry, flat earthers, but this is how I see it anyway. So here,
I see it too.
once you do the maths, I'm not going to do the maths, maybe I'll do that later on. Once I do the maths, you're going to actually find out that this length you can see is equal to, pretty well equal to, at small heights, it's pretty well equal to the square root of, don't forget the square root of, because everything underneath the square root sign is underneath the square root sign. The square root of the diameter in kilometres by the height in kilometres. So when we punch this in, we're at Springbrook. This here is 800 metres or 0.8 kilometres. This here is half of 12,756, whatever that is. This is 12,756 kilometres. So if we punch into our calculator the square root of, hang on, do it again, the square root of 12,756 times 0.8, if we work that out, it works out that this is 100 kilometres. That's what we can see, and we'll take a little shot of that in a minute. We're going to do a video to the horizon to show you what 100 kilometres looks like.
So the triangle that you've actually used, what you actually calculated is...
Ignore those people.
Is this guy here?
They can go around, you can go around.
Is that something to do with... Oh, you never run over.
Nothing. You're right to come around.
You can come around, you can go...
You can't do it.
What's happened?
You can't do it.